Hello to the people on Twitter and on Twitch. Uh, I'm not sure what is the situation on YouTube, but I'm not going to try anymore. Oh, it seems YouTube now finally managed to work. Okay, cool, cool, finally. Okay, that was that's nice. Okay, so most likely the YouTube link is not correct, but that's fine. Let me open at least the YouTube chat window or something. See, at least I can give it a link. So you will see now, you should see now my screen, and uh, yeah, you will see some of my history. It doesn't matter that much. So let's see. So yeah, it seems property-based testing is working. Yeah, there is another URL, but let's give that to Twitter and okay, and that's it. Okay, so let's find the previous message and let's get going. Okay, so YouTube refused to work at the old address. Please see this or Twitch. Okay, so stay here on Twitter. So let me give also the URL of the Periscope / Twitter stream. It seems that it's working. So come on. Sorry, my secondary screen it's a little bit far, so I'm having kind of a difficult time copy. I think this is the one. Yeah. Okay, so this is the URL. Perfect. Okay. 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 So yeah, that's it. Sorry for the delays. 22 minutes later, but at least I think I can. Sorry, I must have lost some people because I've seen people on the other versions. Yeah. So I guess I should just delete this so they are not confusing anyone. Okay. And this is the live one. Yes. And this is the old one. Okay. Continuing. Okay. So let's check that the URL is correct. Yeah, I think it is. So okay, so Restream should be happy now on all the platforms. Yes, everything is okay. Okay, so now since we can get over the technical stuff, um, yeah, I'm at the beginning with this kind of thing, so sorry about that. Um, so I've started in the previous sessions with this exercise called poker. I've done a little bit of I've implemented basically for the platform just so that I got an answer from the mentor. I won't look into the comments right now. In the previous session, I've uh, looked at um, fuzzing using um, where is it? Using HongFuzz, and you should be able to see it here. It's a little bit long. It's maybe 3 hours, about 3 hours, but towards the beginning there is some dead time and some optimization thoughts. The final code from that session is this one. So I will close the cargo toml, and because during the fuzzing session we managed to eliminate some of the bugs that were leading to crashes in our implementation. Um, I think it's more interesting if we go back to the exercise as it was, or to the code as it was before the fuzzing corrections, and try the property-based testing and see if we get something different. In both cases, there should be some improvements coming out of the various techniques. So fuzzing is its goal is to make sure that you have no, let's say, maybe broken assumption in the code that could lead to crashes, or maybe you have incorrect input validation or incomplete input validation and things like that. While property-based testing is trying to allow you to test the code without thinking of particular unit test cases or particular configurations, because we're basically very non-creative, or very lacking in terms of what inputs we can generate compared to a random generator. The difficult part about property-based testing is that um, we need to think of some high-level properties that can be thought of without uh, re-implementing the same code. So this is one of the most difficult things. I've also had difficulties with this. I still have difficulties with this. So let's see where this leads us. I have some ideas how on this particular code I can do some improvements. So let's see, there are some changes. Oh, I think this is a leftover from the fuzzing exercise. Uh, or at least something. No, I think it's a last suggestion that we thought. Yes, this is one of the last suggestions that we thought that. Oh, I realized that in the previous streams the characters were a little bit too, or the text was a little bit too small. So maybe this should be okay. Um, and sorry if I don't see your. Let me see if I can open the chat and maybe put it in a more visible place. So um, open in browser and then Okay, hello chat. Okay, so it seems all the platforms are getting the chat messages, so um, if you have any kind of comments, uh, you can put them there. I hope it will jump into my corner of my eye, so can answer any question you might have, um, or maybe try to answer them. So yeah, so where is my mouse? It's on the other screen. Okay, so now that I've poker not explorer, yeah, not sure what is. Oh, this is not sure why it's looking like this. Oh, yeah, okay. This is the fuzzing. Yeah, that's why it was looking so weird. Okay, so the change that we're seeing here at the bottom. So it seems that my mouse started to act up. So so the change that we see here, it's actually one last idea that I had, that probably property-based testing would um, be able to identify more than fuzzing, as fuzzing is directing you to find invalid inputs that generate crashes, while property-based testing is trying to check things that are true about your code. So okay, so just let's just git reset hard on this tag, which is the exact same version that we started with when we started the property, the fuzzing. So not sure what is happening here. Okay, let's just say cargo check, just to make sure that everything is okay. Cargo test ignored. We should have 27 tests passing, and which are from the exercise, and another set of um, tests of our own, which are actually run by default. Yes, 23 tests passed. So these are tests which are implemented here in our test module here. So okay, so first things first, what is property based let's say basics in terms of Rust? There are several let's say several mm, crates that help in this area. So if we go to crates.io and we look for uh, property based testing or quick check, quick check being the first implementation of this idea of property based testing, which is originates in Erlang. We see quick check macros, prop test, and so on. So today we will not use quick check, because one of the thing that this documentation points out to is that somewhere towards the bottom, I think, yeah, alternatives Rust creates for property testing. The prop test crate is inspired by hypothesis, and the prop test crate says it improved the concept of shrinking. So this is one important aspect of property-based testing, because what property-based testing is, similarly to fuzzing, is generate inputs, but on the other hand, when we generate those inputs, we could run into a situation when one of our properties, and we'll see what that means, doesn't hold true anymore, and it is essential for the developer for that input to be so-called shrank down or minimized. That means that, for instance, in this case, you see that the first we will go a little bit through this example, but we first let me give a high-level idea why shrinking is important and why I chosen prop test. So in the first input that our property, which is, we could say it is kind of equivalent to a test case in other types of testing, where the test case failed. So this, for this input, so this is a year, a month, and a day, and this failed. And at some point, as you can see, it converged. So the application, the crate actually converged on this minimal use case. You can imagine that if you have with a year, month, and date, this is actually some kind of let's say kind of difficult to understand, and it is the typical problem that we engineers have in production. When you look at some kind of code, we realize, okay, we have I don't know, an on and off issue, and that happens to occur. Oh, I haven't, you can't see my face, so let me um, so let's, okay, so now you should see my face, sorry. um, so this is important because in production or in a test case that is generated with some large input or very complex input, all the noise that is just not necessary to reproduce the test, the issue, is basically making the job of the developer to understand what is the problem a lot more harder. So you can understand that, let's say, if this is the test case that fails, or maybe this is the first test case that fails, if you look at that, that looks, well, you don't know where to pick it from. Does the year part matter? Does the month part matter? Does the day part matter? And this is the job of prop test and other and quick check in other languages to reduce this test case to a minimal use case and test case, and this is what is happening here. Going back to the beginning of this idea, so this is the, let's say, the documentation of prop test, and this is a test, a simple let's say code that should showcase what should be done for prop testing, and we will adapt this, we will understand this, and we'll adapt it to work in our case of the poker hand kind of exercise. So in this case we have some kind of function that parses dates of the form y, year, month, dash or minus, month, dash, d, which is the day. And as the exercise says, it's not worrying about validating the date. Any kind of triple of integers is fine. So the proposal is to start checking if something quick is working. So this is the example that is given as an initial exercise. So let's copy that so we can see what this is all about. So I will start a new window just to make it a little bit more clear. So where we work, I'll open a folder, and let's just say where is it? Okay, so let's create a new folder here and say prop test live, and we will press OK. So we can open a terminal here and say cargo new and dot, and I think what we need is a name. Let's see what's the syntax. Path, new option, bin, name. Oh, it's minus name. Okay, so minus name, and say prop date, and we'll make it. Oh, okay, it doesn't like that. So let's just say, just do that, and then move prop date everything into the current directory, and now we can also move this here, and we can remove the directory. Okay, so instead of our main rs, let's just say we use the example, and we will also need to add prop test, which is our crate. So if we go to our where is it? Oh, I closed crates. So if we go to the prop test page on crates, it says that you should add prop test. It seems that the latest version is 0.10.0, and our cargo toml. Oh, this is not. This is the poker part. Okay, so cargo toml has prop test 0.10.0. Okay, so we have my main.rs. So let's just make this code nicer first, and then just say cargo run. See what's going to happen here. So oh, I think this should have been a library. Yeah, because this is not going to do anything. Okay, so interesting. Yeah. Oh, yeah. I guess we can write some tests. This is the example. Okay, this is a classical way we do it with unit tests, but this is how you do it with prop test. So yeah, in this case, yeah, there is some dead code. I'm not sure I should change it. Let's give it another try. Okay, so cargo toml. I'm not actually sure how I can turn this in easily into a library. So let me start over, or at least try to see if renaming this to lib works. Something new every day. Where is the chat? Oh, come on. Okay, here there is the chat. Okay. I'll just close this for now so it doesn't confuse me anymore. Oh, it's a dev dependency, not an actual dependency. Okay, first things to remember. Okay, so yeah, of course, prop test, it's not actually going to be used on the deployed binary. It's something that we use during development and during tests. I guess we can change that now. But first, let's try and change this into a library. Let's see if this just works. And deleting this works. Let's see. And again, copy from. Oh, it's that code. Okay. Okay, so it's that weird how it says function main and then parse state. Okay, I wouldn't have expected this. But okay, so let's see. Um, okay, so let's try it in the same file because it's easier. Let's see if it works. Okay, so just say, since it's a test function, let's just say cargo test. Function is never used, not found in scope. Yeah, this is weird, the way that the code was formed basically. Just to give an authentic kind of experience, I don't prepare much in advance, so I'm learning as I go with you. So let's try again. Okay, this looks better. It says one failed. So in our case, it says okay. We have a crash. It seems that I have no. Okay, so let's see. So in my case, byte index 4 is not a char boundary. It's inside whatever this is because I don't have apparently the font to display this. And if we go back to the exercise, you'll see this is exactly the same problem, even if it's not the same input, as it was suggested that it will be found in our case. So let's see what is actually happening here from a property point of view, a property testing point of view. So the assumption here is that we don't crash, and that's the function. It doesn't have any special meaning, and we get an S, which is a regular expression. I'm not yet sure why. What is this exact regular expression? But I've read just a little bit in advance. I haven't prepared much. I just read this to get an idea what is going to be the topics that what are going to be the topics I'm going to discuss. It seems that the assumption is that we will generate some kind of stream of U8 characters, and we will give it to parse date, which in fact expects a stir. So because not every U8 character is a valid Unicode point or UTF-8, you cannot simply slice strings. So this is actually what is happening here. So it says, okay, as long as the input is not so the initial code, so going back to this, the initial code says, okay, if the length is different than 10, we just return none. So we cannot do any kind of splitting of year, month, date. Otherwise, we split between and we assume that we have minuses on the various positions, and we split at positions 4 and 5 and 7 and 8. But as you can see here, I think this is exactly the place where, yeah, it crashed. So it says byte index 4 is not char array, and this is in, where is it? Where is it? Should be a line byte index inside. Okay, mod data res. Oh, the output is not very helpful, so let me collapse this so we have a little bit more space. Yeah. Oh, here it is. Lib.rs page line 25. So let's see. So this is, oh, actually it went past that. No, it didn't. I don't know what happened, but it seems that for some reason 25. Oh, it is actually the prop test. Okay, that makes sense. And now this is obfuscated, so I don't have the actual line in our code, it seems. Yeah. Okay. So the idea is that this crashes because we're slicing into an UTF-8. So this is one first property that we were trying to create according to this example. Just generate something and try to split it in year month date, in year month day, and it failed for this reason. So it says, okay, let's add this to our regressions in our case. So let's just prop test regressions. Interesting. So there is a folder which is called prop test regressions. Okay. Not the best time for my mouse to act up, but okay, yeah, and indeed there is. So okay, so I didn't initialize git init. I don't have a git repository. Git add, just add anything, add minus a, take it ci minus m, and say add prop test example after first crash. Yeah. So let's just remove this because I don't like the symmetry. Okay, so yeah, GitHub prop test regressions. Okay, in this case it says it is interesting to add the failing test case to a traditional unit test since it has exposed a bug. So let's just do that. But we should actually copy the error case that we have. So just to make this more I don't know, realistic, or in the spirit of I don't know what happened. Okay, and try again. Now my mouse, it seems that today it's not a demo gods friendly kind of day. Now I'm doing something wrong. Oh, Control Shift C. Okay, not sure why that is a good idea, but anyway. Okay, so let's just cargo test. Actually this will crash, so let's just ignore this for now. So we can just look at the test case, and it should crash again, but only this time in our test case and at a particular line in our code. So yeah, byte index 4 is not a char boundary, it's inside whatever bytes, whatever lib mode, whatever. Okay, good. So the fix that this exercise is proposing is actually put a limitation if the string the input is ASCII, and if it's not, then return none. So because digits and minuses are ASCII basically. So let's just implement that in our code also. So just say if not s is ASCII, just say return none. Okay, and let's try again, and now it should pass. Okay, good, so it passed. Okay, so now we can re-enable our property test, but even though some of the inputs will still be invalid, anything which is non-ASCII, it will just come as a non-crash because we will return with this. So cargo font, I think it's, yeah, the code was definitely not correct, correctly formatted. So let's just try again. We will, it will run our test, and it will also test Unicode gibberish. Okay, test doesn't crash. Okay, okay, okay. I'm not sure why this is enough. Maybe it didn't generate enough versions of the string, because I was expecting, knowing quick check actually does generate all sorts of inputs, and maybe tests one by default. I think it tests 100 um, 100 let's say mm, inputs, random inputs, and afterwards, if it all of them pass the properties, they can be considered, the test can be considered as passed. So I'm trying to make the monitoring window a little bit bigger, so I can see in case anyone is I don't know, asking for help or something. Okay. Okay. Not sure why the Twitch window is actually acting the other way around. I'm trying to make it bigger, and it's actually decreasing in size. Maybe it's something related to increasing the font and decreasing the window. Yeah, it seems like it. Okay, that's weird. Okay, so let's see. Okay, there is. Okay, doesn't. It's not that problematic. Okay, sorry about that. Um, I'm still getting used to all this kind of secondary screen and monitoring at the same time. Okay, I will look at the chat in case there are questions. Okay. Um it seems that the chat to Twitter is broken. on Periscope / Periscope. Not sure why, but anyway. Fine. It's online, but it seems the chat is not working. Not sure why. Okay. Okay. So back to our exercise. Um, so I was expecting that we would have something like maybe 100 inputs and then get that error. So, or maybe we're no longer rejecting anything. So, okay, let's assume that this is okay and go on further um, with examples here. So another property we want is they say it's that it parses a valid date. We can add another another test to the prop test section. Okay, parses all valid dates. Okay, so what it's saying here is that it wants to add another property test case, and the property it's trying to test now is that if there is a regular if the string is conforming to this regular expression where we have 4 digits between 0 and 9, and then 2 digits between 0 and 9, and then another 2 digits between 0 and 9, that should parse the date successfully. Not sure why the coloring is off. Uh, yeah, it's strange. Okay. Okay. Yeah, it seems that it's correct. Not sure why it's cargo font, cargo check. Yeah, and we might want to change our so our compilation is a little bit faster. We should indeed change to using this as a dev dependency. So let's just say dev dependency for prop test, and in the next compilation we should see some effect, because now it's wasting time on testing this. Okay. Not sure why. So it seems Twitter lost. Okay. Test Twitter. No, Periscope is broken. Not sure why. Not sure how to fix it. I won't care about that right now. Okay. So what we can do now is again cargo test, and cannot find macro protest in this scope. Really? So it seems that there is some weird problem with this, so I won't try to fix it. Okay, parses all valid dates. Seems that it's working. So whatever the documentation was trying to show us is either an actual regular expression. Oh, in our previous tests, backslash PC star generating an arbitrary string composed of arbitrary non-control characters. Okay, now we generate mem. Okay, the new test passes. So okay, yeah, that's correct. That's what we also saw. The new test passes also. All valid dates, they also pass. So yeah, okay. So let's move to something else. The final property we want to check is that the dates are actually parsed correctly. Now we can't do this by generating strings. We'd end up re-implementing the date parser. Of course, that's the whole problem with properties that you want to implement. You just want to avoid re-implementing something that is your actual code. So you want to, the property should be way smaller than your code. So okay, instead we start from an expected output, generate the string and check that it gets parsed back. Okay, so this is a really simple idea. So you know how a valid input should look like. You get some kind of values that you expect the output of the function to be in, generate the input back, and then know what you should have. So in this case, you don't have to generate we don't have to write the parsing function again. You actually avoid it by saying by using format macro from the standard library. So in this case, it says, okay, we generate a y in this range, an m within this range, a d in this range. So it says, okay, y is between, the year is between 0 and 10,000, month is between 1 and 13 exclusively, day is between 1 and 32 exclusively. Yeah. So that, once you have that, you should be able to generate an input string, which should get you back the same input as you had before. So let's write this. Let's try to write this ourselves instead of copy pasting, because otherwise this will not stick into my mind. At least that's how my mind works. So this is a test. It is in the prop test section. Yep. And we say something like a fan. What was the name of function? Parse state back to original. Okay, parse back to original, and we have as inputs we have a year, which says in the range 0 u32, yeah, to 10,000, so it's actually 9,999. We say a month is between 1 and 13 excluding range, and the date is between 1 and 32. Okay, this syntax coloring issue, it's bothering me, so I'm going to comment this. I'm not sure why it's doing it, so I'm going to comment it so it gets back. No, it doesn't get back. So it seems that there is something wrong with the Rust and Rust support in my Visual Studio Code. But anyway, okay. So now we have a y, an m, and a d, which are supposedly valid. So the proposal here is that we have a oh, we just call parse date and get some values. So we get a tuple back because our output is a tuple of 3 values, year, month, date, wrapped in an option. So let's just say let, oh, this is an unwrapping. Okay, let's say y2, or just to copy what they say, month 2, day 2 equals parse date. Was it? Yes, parse date, and then format, and we say so exactly 4 characters prepended by zeros. Okay, 0, 4, and then a minus, and then 0, 2, and then another 0, 2. So we have Y, M, and D, and we unwrap. Typically you don't want to unwrap in production code, but given the fact that we this is test code, and it's the way we detect that something is wrong is by crashing. This is something that is acceptable, also acceptable in prototyping code, and let's say where is the chat? Here? No? Here? Here. Okay. Okay, so we have this, so let's see. And prop test assert equals. Okay, prop test assert equals is basically the same as assert equal, but doesn't cause a bunch of panic messages to be printed on intermediate test failures. Which one to use is a largely matter of taste. Okay, so let's see. Let's use prop test assert eq and see what it looks like. Prop test assert eq, and now say y2, m2, d2, and our ymd. Okay, so prop equal, yes, prop assert. Oh no, it's not prop test, it's prop assert. Okay. Okay. So let's just say, see what happens. Two passed, one failed. So interesting. Minimal failing input y0 m1 d2. Huh. We didn't write our format function correctly, or what? What's the idea? 402. Let's fix this because it bothers me. This warning. Dead code. Okay, and try to run it again. It's interesting. So I have to close this. Okay. So yeah, I get a 0, 1, 2. Left is 0, 1, 2. Right is 0, 1, 1. I think might have written the format function incorrectly. 0 to okay. Let's see how this looks in the playground. So play. This is what I do when I'm confused by some particular piece of code and I just want to isolate it. So this is one, maybe some previous example. Just say let s equals this, and then print line, or we can debug, but that's it. Print line s. Let's see if that works. I think I need a string. No, it's not that. Okay. Yeah. So our case was filing for 0, 1, 2. Just say 0 u32, 1 u32, and 2 u32. 0, 1, 2. Okay. And the right, it's saying, so right hand side, I'm not sure why the right hand side is incorrect. So 0, 1, 2 is left. Oh, it has nothing to do with prop assert equal. I think it's okay. So let's see what if I use assert equal, because they're suggesting that it might be a matter of taste. Okay. Left. Oh, this is what they were saying. Okay, you can see the minimizing happening, which is nice. So 6 to 3, 6 to whatever. Yeah, I think that's nice. I think it's nicer to see the reduction of the test case. So 0, 1, 1. Okay. So it's definitely the day isn't correct. So let's see. So we could do two things here. Either go with the documentation and see what they say. Okay, maybe we get the exact same case that we have here, or we can try to understand ourselves what is the issue. Um, okay, so let's try and understand what is actually happening. So this is the input 0, 1, 2, and the right hand side, so basically the converted values are y2 m2 d2. Yeah, y2 m2 d2. Okay, so oh no, yeah, this is wrong. Okay, so it was actually correct on the right hand side. Actually, it was the wrong input. Okay, so let's try again. I didn't see that. I just wanted to check one last time. Okay, so now again we're in the case that they were talking about. So it started with some kind of complex case, and now it's reduced to 0, So the input is 0, 10, 1, and the right is 0, 0, or actually the left. So the output is 0, 0, 1, although the input is 0, 10, 1. So in this case, they say the problem is that uh, we're off by 1 because the month here is actually 2 digits long, and the way that you can realize this is the case, let's see if with prop assert is we get to see the reduction. Prop assert, let's see. No, we just see the minimized case. Does it say how we can get that? Run with backtrace or backtrace. Okay, so let's see if we run with rust backtrace equals 1, if we get more of the no, I'm not confused about shortcuts. So it should be Control C. So let's see. So cargo test and then Control Shift insert. No. Control Shift V. Oh, great. Okay. Okay, so yeah, it's not the thing that I wanted. So I would say that in order to see what it was before, from what it was reduced to, you could and see maybe the cases where the reduction failed, assert equal is a little bit more helpful, because you can get a comparison on what is a successful input versus what is a non-successful input. So let's remove this rust trace. Okay, so let's see if there is any kind of failed. It's interesting, all these sessions that failed are listed. So in my case, I don't have this nice output. Oh, okay, so it's this is the way that they do it. Okay, so they just insert the print line in the test function at the beginning to get an idea of the reduction. So that makes it a little bit nicer. Okay, so see how many times this is actually called, and this makes it, yeah, that makes more sense. Prop, and this will reduce the output, but we also see what were the tried version of inputs. And now we get, okay, this is it. So 2, 10, this failed, failed, then got a 5, and then an 8 and 9, these were successful, and got back to 10, 8, 4, 2, and then a 10. And indeed this is what it was said in the documentation. So the minimized use case, the successful use case was this, and this is compared to this one, which, sorry, the last one, which fails. The highlight is the fact that this is 2 digits and this is 1 digit. So maybe what we could do is also keep the assert here and see which are the versions. It's a little bit more, it should be a little more obvious which are the inputs that failed, so we don't see, we don't have to, let's say, judge ourselves or suspect ourselves what was the output. So yeah, you can see here this failed, and when you get consecutive inputs without any kind of assert output, these were successful because this assert was successful, so there is no breakage. So these 3 were successful, this is breaking. So I guess this is the way that it would make the most sense, at least for my mind at this point. So this is a successful test case, this is an unsuccessful one, and then the reduction starts. Okay, cool. So yeah, once you see that and you see the last successful case, so this was 9 with 9, the one with D8 is failing, it is clear that the difference is here in the month. So that makes it kind of obvious that you need to look here and you see, okay, 0 to 4 means 0, 1, 2, 3, 4 digits, and then 6 to 7 it actually means just one digit, so there's 6 digits, so 5 is skipped. So if we put a 5 here, it should be 5 and 6, right? I guess, or 5 and 7. So the fourth digit is the minus, and then 5, 6 are digits, and then 7 is a minus, 8, 9 are digits. Okay, so that should make it pass. And it's working. Okay, cool. So now that we saw that this example is the way it should okay, it's kind of giving us an idea how we make properties. Now there is idea of prop test from the bottom up. I don't think it makes sense to go through this right now. I think we can try to apply as much as possible what we've seen up until now. It seems there is some kind of way to generate inputs. Okay, so we can generate enums. Currently somewhat limited. Filtering, let's see what's filtering. Compose, prop compose. I think for the property test that we have, so it says okay v and whatever, and then you have prop filter, and there is some kind of filtering happening here. Okay, I guess that's fine. Okay, so let's go to our poker exercise and try to apply what we've learned. New window and open the poker exercise, and in our poker exercise this is our code. So in our poker exercise, the main input, the one that is provided by the exercise from Exercism, is this. We have a function winning hands, which receives an array of a slice of stirs, and it should return an option with a vec of all the winning hands. So the first thing that we could do here is just start with a similar example as it was in the prop test book, and let's just generate some random string as input, because we have a slice of stars, and you can give it just a slice with one hand, or maybe two of them, and see what happens. So first let's cargo and prop test. Not sure why the dev dependencies wasn't working, but I won't bother with that. Okay, so now we have cargo toml modified. We have prop test. Okay, and we already have a lot of code here in our exercise, so but we also have a section with tests here, which is collapsed, and we could use that. Okay, so what we need is prop test prelude. Prop test prelude. Okay. Okay. Hello. Oh, we have somebody watching. Hello on Twitch. Okay, hi. Okay, I'll go back to restream. Okay, I'm a little should get used to this. Okay. Okay. So now what I want to do is to do a similar thing with my own code here, and just mod test, use create. I guess I could add it here. So just say use prop test prelude and import everything from, and we say, I think there was a there is a prop test section. Let's go back to our own example with strings. So I'm getting distracted by the streams and okay, sorry about that. Okay, so let's do that. So we should also try it doesn't crash, and we get a prop test section, and say prop test doesn't crash, and we want to put so we want to give it as a slice, so let's just give it 2 slices. So just S1 in this and S2 in the same regular expression type of code, and we just say S1, S2, and we have some references here, and not parse date, but where is it? Oh, come on, leave me alone. So hand rank, oh, where is it? Test outline, oh, winning hands. Where is it? Why is this not listed here. Oh, they're alphabetically sorted or what's... No? I don't know. Okay. Winning hands is not listed here. Not sure why. Okay. So we get winning hands and we get the Vivek. Okay. So let's go back to our code. Say this. Oh. No. Definitely not. And of course we just need to call it. And okay, so this shouldn't crash in theory. So let's just cargo test. But it will, because these are I think my code is also suffering from the same assumption as it was before, or it might be that it's correct because it might be splitting with the chars function and doing searches by stir friendly or string friendly kind of things, but it most likely will crash if we get into hands and get some kind of random which doesn't look like a hand. So the poker exercise gives us input as valid input this kind of string. Where is it? Here. So rank and the suit. So and have 5 groups, 5 such groups, and most likely this will crash. Yes, it did. And it panic attempt to subtract with overflow. Okay. Future failures, prop, regression lib. So yeah, interesting. So with empty strings, with empty string, this code of us failed. Okay, so empty strings are or empty stars are not okay, because we're attempting to subtract with overflow, minimum failing inputs, nothing and nothing, and lib.rs 243. This is our line, and let's try and also print them so we get an idea of the reduction. So let's just print line, say s1 equals to this, and \n, then s2 equals to this, and then s1, borrow it so we don't lose it, s2, also borrow it, and see what's... no, okay, it's fine. The analysis was a little bit behind. Oh, I accidentally started shortcut. Not sure how, but I did. Okay. Okay, so this failed, and I can see, let's see. Oh, so we have some panics. Okay, so it's interesting. So yeah, this is maybe this is something that it's kind of different to fuzzing in the sense of um, for fuzzing you the at least the honk fuzz input was trying to go from very simple inputs to more complex ones and trying to rely on code instrumentation to make sure that all the code paths are mm, activated by the test cases. So whenever a crash occurred, that was recorded, and um, the assumption was that you want to get as many crashes as possible with honk fuzz. But with prop test, what you actually want is, and they're also minimized for honk fuzz in the sense of, okay, I know this kind of input generates that kind of crash, and it also tries to minimize that. But for property-based testing, because the default is to start from something complex and minimize it and make it as simple as possible, the the consequence is that you focus on very simple test cases first, and you build up more and more. I think with fuzzing, you it's more like a stress test. So it's more focused on finding some hidden assumption in the code and things like that, while property-based testing is kind of focused on um, if you write the correct property, then you can see, okay, this doesn't hold true for your input. So now we just said, okay, whatever inputs which are valid, we should get something which doesn't crash, which apparently isn't correct in our case. So I think I'm going to reorganize the code a little bit because it's going to be a little bit weird to jump back and forth, or I can do splitting. Okay, so let's just do that. View split, where is it? No, I think it's here. Split, right, yes. Okay, so let's minimize this and this for now, and on the right side we will have the code. Okay, so what we can do is because our tests are failing for empty strings, um, we could add these test cases at our regular unit tests and see what happens with these test cases, because it will help us to understand where the code crashes. As you can see, uh, where the actual code crashed in our own function is kind of obfuscated. It only says librs 128, which is the where is it? The come on. Okay. Oh, it says where it crashed. Okay, it's fine. Okay, so yeah, in the fuzzing testing, you also had a similar use case, so a similar detection. So okay, so let's rewrite it in in a little bit more nicer way. And the assumption here is that whenever a stir is received in this function, so this function is a so-called constructor for the card struct, and it should receive something like one substring of this type, so 3H, 4H, 5C, something like that, 10D or something like that. So if and the separation happens in spaces. So the assumption here is that if the length of this card group is less than 3, um, and I don't think it's equal. Oh, actually it is, because you can have a 10 or something and it's equals to 3. And the assumption it is that it is of that size, but in this case um, it is an attempt to subtract with overflow. Because the len is 0, we get this kind of issue. Because you had a -2 and something. So now the crash shouldn't happen in this kind of situation. So let's try again. Our rewriting of the code did that. Okay, so now it says we had still an empty string on both S1 and S2, and we call option unwrap on a none value. So let's just see where that happens. Yes, indeed. So if you get an empty string, you get cars, chars, rev, and then unwrap. And because that is empty, you have no chars and you have nothing to reverse, and you get nothing on the 0th position. So you get a none from the beginning. So if you try to unwrap, that's indeed incorrect. So what we could do here is to so what we could do is change this new function to return an option self, and that would allow us to make sure that if we have none here, we can bubble it up, and then the caller should be able to handle it. So that would be a function that would try to generate cards. But I think this is not as interesting. So I think it's a little bit more interesting to find some kind of properties that are interesting to our poker hands, because I think we're going on the same path as fuzzing, and that's not interesting. So one idea which I had at the end of the third um, what happened? I think Twitch got disconnected, or what happened here? Okay. Seems that my computer is a little bit busy with trying to keep up with the streaming and monitoring. Okay. Yeah, I'm hammering the connection. Probably is getting some problems. Okay. Yeah, Twitch came back. Okay, good. So so going back to our let's say, where is it here? Okay, so oh, come on. live. Yeah, one of these is live. I'm not sure. Okay, sorry. I'm still trying to figure out all the streaming directions, so I guess I should just leave it as it is, because I'll put the recording at some point online. Okay, so I think it's a little bit more. It will be a little bit more interesting if we try um, to come up with some properties that are relevant for our poker hand. So what we could do, using the last example code from the prop test, we could generate something that we know for a fact that is a valid hand. So something like, okay, we generate some kind of random character between or number between 0 and 4, sorry, between 1 and 14, and we generate some random suit between the 4 suits that exist, and we combine them, and we generate 5 of each, and then we combine them, and we could do that maybe twice, or I don't know, we can generate 10 of them, and you could we just make sure that we are able to parse it. So this is a very easy property to test. So in theory, if we know that our rank is between 1 and 10 plus Jack, Queen, King, and Ace, and the suits are our correct suits, we should be able to always get some kind of rank, or at least decoding of the hand. The problem is that our code is kind of smart, and special cases this, because as you can see here, if hands of Lenin is equal to 1, then it will always return that first that star, which is it's the hands 0 in that case. So we need to generate at least 2 hands, valid ones, to make sure that our logic is correct. So I would say it's going to be a little bit more interesting if we do this instead of trying to fix this or go the route of fixing this property. So let's assume that our input for this is expected to be always valid in that sense, and let's write some properties for that case. So where is the code here? So let's say we want to generate so we generate something between 1 and 9. So we can generate or a 10 or an ace, no, or a jack, queen, king, and ace, or we can have a 10, and after that we generate a suit, so it will be hearts, spades, clubs, and diamonds, and we do that with a space and generate it. Let's generate 10 cards. So let's generate 10 cards and we will split them. So we don't need a second string. We will split it inside. Oh, this is wrong. The parsing issue has came back. Not sure why it's doing that. So annoying. So I'm not sure what is the. Let's just say we generate. This is, yeah, the accolades are messing it up. So I think it's assuming that the accolades should be actually the opening function and doesn't know it is somewhere between the it's within a string. So what if we say raw string? No, it doesn't. So I guess maybe that's one reason to install Rust Analyzer at this point, but I won't stop for that. So okay, so we generated 10 cards which are followed by spaces. So what we can do is split them. So no, actually let's just generate 5 and just generate 2 of them and just say S1 and then S2 and just generate two cards, 2 hands, sorry. What happened? No, this is wrong. Okay, okay, S2 is this, and let's just say winning hands, strip and strip. So we remove the final trim. Is that the function name? Yeah, seems like it. Trim. Okay, so we trim the final space because in either case we generate a card and a space. We generate 5 of them, but the final one is not necessary. It might mess up the parsing in the winning hands, but let's just not care about that now and see what's happening. What will happen in this case? So in theory, whatever happens is that we should get some kind of winning hands, whatever, whenever this is generated. So yeah, it seems that doesn't crash. Okay, so let's rename this to say not doesn't crash on valid hands. So this is one property. Another property is that we could think in terms of what. So the purpose of this exercise is to make sure that we get the winning hands from this set of hands. So what we know for a fact is that there are some rules which say that straight flush always beats anything else. So unless the other hand is not a straight flush, unless the other hand is also straight flush, we can always check for this property. So straight flush should always beat all the other combinations of valid cards. So I think this makes for an interesting, more interesting case. Um, but probably we need to look into the documentation because we need to find out how we can filter. Okay. So the way we can guarantee we don't generate a straight flush is to make sure that no two suits are identical. So at least we have, or at least we have one difference between the suits. So we could say something like this. So um, oh, this syntax highlighting is messing with my head. So what we could do is say we have how can we generate this more easily? We could generate I don't want to re-implement the parsing, so values must not be divisible by 7 exclusive or 11. Okay, this is some kind of input. So how could we do something similar here? I honestly don't know. How about if we naively assume that whatever is randomly generated is not going to be a straight flush, and even more than that, it's not the biggest straight flush possible. So what if we generate one S1 and let me just say, oh, this syntax highlighting is so jarring for me. So we say nothing beats highest straight flush. So we generate something, and well, we can generate two of them, but we also say const highest straight flush, and this is something like so it's ace, king, queen, jack, and 10. Okay, so let's just say jack of, it needs to be the same suit, jack of diamonds, it doesn't matter in which order, so let's just say 10 diamonds, jack of diamonds, king of diamonds, queen of diamonds, and ace of diamonds. And this should be the biggest one, and it is a star. No? What's the complaint here? Constant. Oh, it's not ever used. Yeah, it will be soon. So trim and then just say highest straight flush, and if we assume that nothing beats the highest straight flush, then we should always get a sum, so we can unwrap, and we say the length of it is equals to 1. So let's just say prop assert EQ winning hands is 1. Okay, this syntax highlight is so jarring. Okay, so let's just move this aside and let's see this test hopefully fail. And we will also see the successful cases. Oh, okay, great. We have some debugging. Yeah, so jack of hearts, ace of hearts, 10 of hearts, king of hearts. So this failed. So let's see where are the debug statements and print lines. Debug. Okay, let's just comment this and try again, so we just see the output from the test case. Another interesting thing to do is when you get this kind of less performant version of a code, whoa, no, it's okay. So jack of hearts, ace of cards, 10 of hearts, this is the one that failed. I thought we had something like, wow, 1. This is incorrect. There shouldn't be a 1 actually. Okay, this should be a 2, but yeah, we assume the input is roughly valid. So another interesting thing to do is once you get some kind of suboptimal kind of solution of a problem, you can maybe think of a more performant version, but for which you're not sure that you have the right implementation. So in order to be able to have a drop-in replacement of the implementation, you could write property tests that say whatever the old implementation returned, the new implementation should also return. And in our case, one way of So in our case, the ranking currently uses um, so is it Zen mode? Is Zen mode in view? There was a way to go to a so-called Zen mode where it would show on the entire screen. Appearance, Zen mode, Control KZ. Okay, so not Control key, Control Z, Control KZ. Okay, so um, our inefficient way of ranking currently the card is by um, creating from the input stir a hand rank and then comparing the hand each of the hands. So we get a new hand and we classify it, and then in the end once that is done we sort them by pairs, and we can get the groups and so on. That is used here when we classify, and then when we compare we have these long match statement. So we have partial ordering for two hand ranks, and this is due to the fact that our hand rank is an enum with all these variants. But more simpler way is to make sure that we assign some kind of score to each of the hands based on the classification. And in order to be able to compare straight flushes with straight flushes, we need to, for instance, we need to make sure that our rank of the straight flush, as we classified it. So if we look at the hand rank definition, we have all the enums have an associated vec, but in the case of straight flush there is only one value, and this is the biggest card in our straight flush. This includes also the rules related to the exception rules that relate to the ace. So what we can do here is to let's say have a kind of base score for a straight flush, and then we add to that the rank of this card here. So if we have a straight flush of a rank king, for instance, in our case we turn that into a number, king being a 13, then we have a straight flush of a rank 13, so we have a base score which could be a U32 or maybe U64, how many we think we will need, and we say, okay, whatever straight flush we have, the base score of the straight flush is starting from here, and then we add on top of that the rank of the card, of the biggest card of the straight flush. So we then can always have a signed score for all the hands that we could have. Similarly for four of a kind, so we can have a range within which four of a kind scores should always lie in, and this makes a very nice um, um, architecture to make sure that our properties hold, because we can always say whatever score we have, if our hand is classified as a straight flush, its score must be within this range. So it must be bigger than this, and it is lower than this threshold, which is the ace threshold. So basically, a straight flush, as ace straight flush, is the biggest hand in the deck, so no hand could have the score bigger than that. The nice thing about this idea is that it simplifies the calculation um, of comparing the hands with each other. So instead of this match statement, we just have a nice arithmetic comparison. Is the score of this hand bigger than that? Then that's what is partial ordering the results. So we can just have the partial ordering of the scores. So the partial ordering of the hands become a total ordering of the numbers associated to them. And another thing is that if we implement this in parallel to our current implementation, then we can always say our score-based solution should always return the same set of winning hands as the base implementation with this long match statement. But that means that we need to implement somehow functions that are associated with hand rank type, which can live at the same time as the our comparison of hand ranks based on this long match statement. So I'm unsure. Is there anyone in the chat or any of the streams that would like to have a go at this? Do you have any suggestion which way I should go? Let's try. I see on Twitter/Periscope there is some viewing going on, but unfortunately the chat is exactly disconnected from that platform, so I cannot synchronize that with with Twitch and YouTube, so I don't see any comments that happening there. So let's just Periscope. So let's just see if I can. Okay. Sorry if you caught something from my stream and the monitoring. I'm not sure if you get it. So this is live one, and I don't see. Okay. Test. Oh, so now it connected. I see the messages from Periscope, but it seems that from the other platforms I cannot send back. Test. Now it's connected. Okay, cool. So now I see all of them. Not sure why it wasn't working before, but it seems now it's working as expected. Okay, cool. So any preference? Going once, going twice. So let's see. We have been assuming that when we have a higher straight flush, there will not be any kind of hand will be having that. So of course this failed because um, our test can generate that input that can match. So as you can see here, we generate some hands which are valid. Apparently, yeah, it's interesting. It generated hands with sorts with lots of tens of hearts and a lot of repeating hands. So I guess we don't have a single deck of cards. We have multiple ones. But then it generated in the end Jack of Hearts, Ace of Hearts, Ten of Hearts, King of Hearts. So it generated a straight flush. And of course this disproves our property. But I think we can refine it if we say, okay, nothing beats the highest straight flush if there isn't an ace in it. And that should hold because the highest um, straight flush needs to have the ace on the biggest as the biggest card. So if we don't have a card, we don't have an ace in our hand, 100% that should never, the highest straight flush should actually be the highest hand in the deck. So let's just remove the ace from the values that are generated, and this should always beat everything else. It's a little bit let's say kind of sledgehammer kind of approach, because we could generate all sorts of other let's say all sorts of other oh, nothing beats highest straight flush is repeated multiple times, or at least twice. Interesting. Okay. um, but yeah, so ranking helper. Okay, so in the past our tests were split between hand test and helper test. So let's just use some kind of namespacing here. Let's just say prop, some kind of primitive namespaces. Okay, so in this case we are sure that our property holds true, roughly sure, because our random inputs might not be in the lucky ones, but once it's generated we can reproduce it. So yeah, nothing beats highest straight flush, and I was saying this is a kind of hammered kind of uh, oh, it's interesting. It's interesting because we generated S1 and S2, but we said only for S2 cargo format. Oh, it's confused by this. Okay. So we said, where is it? Come on. So we just said S1 can have an ace. Oh, and this has a 1. So yeah. S2 must not have an ace, but it wasn't able to generate any kind of straight flush on the first position. So actually this should fail at some point, because we should be able to generate a straight flush on S1. But no, it seems we didn't. Wow. So is there a way to increase the number of... There should be a way to increase the number of inputs. Generate recursive. configure failure, test timeouts and forking. Prop tests are running in process, allowed to run however long it takes them. Okay. Not exactly what I want. So prop test. Okay, so let's see. How many times does it repeat? Maybe it says on the documentation on craze.io. No. It's 12:30 my time, so I should be going to sleep soon. Okay. Arbitrary, many different strategies for the same time, plenty built in. Limitations. Given infinite time, probability testing will eventually explore the whole input source. Yeah, but how do I make it try a little bit more? Because the default number of test cases might be executed for a test case. The whole to pass is 256. If you're not satisfied with this and run more or forever, there are few ways to do this. Set an environment variable prop test cases to a value that can be successfully parsed as the U32. Okay, so that sounds reasonable. So let's just say prop test cases and equals, let's say 1000, and then cargo tests. It will take a lot longer than before, but it still didn't fail. Okay. 10,000. Failed. Cool. So now we're getting somewhere. So this is one of the limitations of property-based testing, because it's kind of a random input. You could run it once, twice, or multiple times, and it will. The fact that the property-based testing is passing is not a guarantee that you have no bugs. Just as there is no guarantee that if you, let's say, run some fuzz testing on your code for I don't know how many hours, you don't have any kind of issues. But since fuzzing, at least HonkFuzz implementation, relies on code instrumentation to try to activate all the code paths, then at least there is a reasonable chance that you would eventually exhaust the input space for that object under test. So yeah, in this case, the expectation for me was that S1 would be the one that has a straight flush, and Queen of Hearts, Ten of Hearts, King of Hearts, Ace of Hearts, Jack of Hearts. Yes, and that finally generated a straight flush. So yeah, this is one of the issues that the limitations that property-based testing has. It's not guaranteed have to have so you have bug-free code, but at least you're close. Um, so let's write another. Um, let's try to assign some kind of score. So let's try to write our score function, which takes a hand rank, and implement that while at the same time we and we use that score to compare the scores of hands versus the current partial compare implementation that we have. So yeah, we we could say, okay, we implement partial ordering for hand rank, and whatever comes out of partial compare for whatever hand we have should be identical to what our um, score based. So once we have two hand ranks, if we generate the scores for them, they should give us the same ordering property as the partial compare that we have here. So the first step to understand this kind of ranking is let's take the worst case scenario and try to understand how we can make sure that we don't have any kind of weird situation where we're confused about um, which is the score of a hand, and we let's say confuse that score with a lower, normally lower ranked hand, because we don't take into account that we, for instance, if we have one pair, we should consider first the rank of the card that forms the pair, and then all the other cards that are in the hand that are, let's say, extra to the pair. So um, what we could do is just implement a very naive kind of way to calculate this score, and let's assume that we will take this approach and say we don't think about this ordering, and that it's important, and we say we have a base score for each of these, high card, one pair, two pair, whatever, and we add to that the value of each card in this vector, and that is our initial stupid implementation of a score, and we compare those and say, okay, whatever those the comparison of these scores is, should be the relationship should hold true for our partial compare. Um, so let me remove this so I can only see the hand rank partial ordering, and let's just say git add -p, say add prop test, no, yes, yes. So this is our property. Yeah, so we could uncomment this so it is the correct code that we used, and then recomment it. So let's just say no. So we commit the correct code. We don't do this. Okay, and just git ci say minus m, and say our first properties in our in poker legacy code. Okay, it's legacy because we are actually on a different branch now. Our fuzzing branch is a little bit improved, but our prop testing branch is, let's say, diverging. Okay, so let's do as we said. Let's just implement some kind of score. I'm not sure if there is any kind of we could implement some kind of trait that transforms our hand rank into a U32. That would be nice. Let's try that. Let's see how that is done. If we find our Rust lang stand. Okay. Now let's just enter the exit then mode. Okay, and come on. So let's just say parse maybe. Stir parse. Is there a parse trait? Parse from stir. Okay. Partial to string. Now I think I actually need something like from convert from convert from. Okay, so let's just see. This is kind of abuse, but yeah. Perform the conversion. From infallible, from try from int error, from kind error kind to error, from segments. Okay, so the trait says we have a T and then we get a self. I guess we need the into valid value conversion that consumes the input value. The opposite of from. One should avoid implementing into and implement from instead. Okay. So I guess we should say from where is that trait? So from hand rank so we should have a T which is a hand rank and goes to a U32 for instance. But I'm not sure. um, how that should look like. Oh, sorry, more. Have to take a break. Seems that there is something wrong with my chair. Okay. Transition. Okay. Now it should transition and it should mute. And transition again. Okay. Well, it seems the mute isn't working, but anyway. Let me get some get some water and rearrange the chair here. Sorry. Okay. I'm getting a little bit numb. So you should be able to see me soon. I got a bottle of water. Okay, so now that we're okay, I got my chair situation fixed up. So impl from for AP address. Okay, so the input is this, and you get something. So we could impl from hand rank for U8. Oh, sorry, U32 maybe. Okay, so let's get a calculation, see how we should, in theory, what would be the maximum for any kind of hand. So, as we said, we have um, a naive implementation where we assume that we don't realize that we have to take into account that the first card in a hand, the second card in a hand, and so on. That is should weigh differently, should have different weights. So the bigger, um, so it's the so for instance, taking the example of full house, because there are just two cards, it matters if on the first position in this vector there is the rank of the card which repeats 3 times versus the card that repeats 2 times. So we naively assume that we didn't realize this, and we should get our property based testing realized, make that clear for us. So we commented this code, and okay, let's just also save the removal of the comments and just say no ci remove some of the comments for my exercism mentor. Okay, and we will keep this unversioned. So assuming that we don't realize that we have these 2 cards and the card repeating 3 times should have a higher weight in our full house score than the next one, we could say, okay, we have at most 5 cards, and the biggest rank, numerical value rank, is an ace, which is a 14. So at a maximum we could have 70 points between the, let's say, the base score of a hand and the highest one for that hand. It's not actually correct, but let's assume that's how we do it for now. So that means that in theory, in order to ensure that a high card, whenever we have a high card that always has a lower score than a 1 pair, we should have the base score of 1 pair bigger than our this maximum offset in our score based on the cards. So let's just write, let's just say we implement impl from what was it, from is that how it's declared? Okay, interesting. Okay, so what we actually impl is impl from hand rank for U32. Yeah, let's okay, so taking this further, we could say, okay, if this is the offset of any kind of scoring, the maximum offset of kind of scoring, again, this is just naive, I know it's not correct, we could say, okay, if any base score of any of these hand types starts 75 points higher than the previous one, then it is ensured that the ordering should be okay. So for instance, to pair should have a base score of let's say 2 multiplied by 70, high card is a 0, 1 pair is a 70, let's say 75, right? So let's say our jumps between each of the types of hands is 75. The score for that is 75. So the high card we have a 0, 1 pair has a base score of 75, 2 pair has 150, and so on and so forth. So let's just say that, and we say we have a const base, I'll say max cards, max cards offset and we could say this is a U32, or we could say this is a self, right? Because it's a U32 and it's equals to 75. But this is generating an error, most likely that I don't have the interface that is implementing, and there is no const associated with the from trait. So it says const is not a member of trait from. Yeah, that is correct. So what is expecting from is missing from this implementation. So let's just comment this for now and just say fn from, and what's the signature? We get, where is it? From segments, and then the type, and returns. Okay, so from and rank, and this is hand, and this could be a reference. We don't care about owning it, and we return a self. And here we could move our const, because now we have no restriction on that, and let's just return 42 for now. So we have some a happy compiler. Expected enum hand rank found and rank. Okay. Okay, so let's just say we get from hand rank. Yeah, now it's happy. Okay. Can't use generic parameter from outer function. So I'm gonna get by you simple. Let me move this here so I can see it a little bit more clearly. Can't use generic parameter from outer function. Use generic parameter from outer function. Self implicitly declare here by the simple. Okay, can't use generic from. Okay, use a type here instead. Okay. Okay, so I guess that should be a U32. Unfortunately, lowercase. And what? Okay. So now what we could say is just have something like let base score equals to match, and then we say hand, and if hand matches with a straight flush of whatever, then we have a score of max cards offset multiplied by, and now the value of having this split shows. No, actually let's keep it like this and split it again. Split. Okay. So we could just go to the hand rank implement definition. So okay, we just need to see the types. So straight flush. Let's just say, let's take them in reverse. Oh, actually we could copy them from here and then block edit them. Okay, and say this, and then Oh, and actually I think we could also add the sum of the vex here. So yeah, the associated type has this. So let's just in all cases we could have a vec. So let's just say we replace the vec of u8 with say ranks, no cards, no cards. Let's just say card ranks. See, really. Okay, yes. No, we don't want this. So now we could replace card ranks, comma, and whatever if we replace regular expressions, and we could replace that with the same card ranks, but we need to escape parentheses, and we can replace that with this and say card ranks dot iter dot sum plus max cards offset multiplied by, and say, let's just say 0 for now, and that should be it. So replace okay, so why is it not happy? Can't find tuple structure, tuple variant, state flush. Oh yeah, we need to say we use and rank whatever is there, so it knows about that. So now it's happy, but base core it doesn't have a type, so we don't need this anymore, and we can say huh? Expected U32 found unit? No, this is outdated stuff. Okay. So let's just see. Let's just say cargo check. Seems the analysis was a little bit off. It's outdated. Okay. Oh, yeah, sure. This shouldn't be a base correlate, it should be a match. Okay, it wasn't outdated. So now it's correct. So realized later. Okay. Some. Okay. Strange. U32. Some is looking for. Some is not implemented for some lifetime. So what am I missing here? I'm not sure what I'm missing here. Okay, so playground. Let's see, play Rust Langwork. What does it say? So we have so it was saying that we have a vector of U32s. Maybe we just need to so iter sum. Some reference to lifetime A. Yeah, so I don't understand what is the problem. Because the reference to U8 is not implemented for U32. So come on. Something stupid. Most definitely stupid. So let v equals vec of 3 for 23 u32 and then 0 14 and let's say v dot what does it take as a sum? It takes an iterator. Okay, so it should say v iter dot sum. Cannot infer type, declare. Cannot say start iter or sum. Iter. because it was saying it was implemented. Let's see if this works. Undeclared lifetime, yeah, sure. Just a underscore. No. It's strange that it says that it's implemented for U32 as stud editor. I don't know. So I guess the simplest way to do it is you just say map and say whatever is an n or x, just say x and this sum. Let's see if that works. Okay, that's it. So if I remove this, it should work, or I'm just thinking wrongly about the references within the iterator. Oh, it should work. So yeah, yet another situation where I'm going around, chasing around my tail unnecessarily. What's happening? Straight flush. What do you mean you cannot infer the type? I just told it should be a U32. There's something wrong here. Ah, okay. Oh, these are U8s. That's why. Okay. So now it should complain about the next one. Yeah. So as U32. Oh. So no, actually I should change. So I should change these as so now it complains that there isn't a way to U32, yeah, from okay, so card ranks ether, and then I should turn that into a U32 so I can add them here. Otherwise I would wrap immediately. So let's just say I replace card ranks iter with card ranks iter dot map and say x, say x as u32 and just say replace. Okay, and now it complains that it cannot cast it, so instead of x as u32 whatever, I could say this is a reference and we can replace that with so this is replaced by this. Whoa, there's something wrong. Identity. Okay. Yeah, here is a mistake. Copy paste mistake. Oh, this I just incorrectly replaced it. Okay. Cannot infer. Yeah. So instead of sum, without this, you say sum with that. Code is really repetitive, so most likely it would make sense to have a I don't even know how to say to unpack the I guess I could use a similar trick as I had here and use just one variable as vector, so I just use two matches. Yes, that would be the better way to do it. So yeah, let's see if this cargo checks or not. Yes. So now we could in theory just leave it as it is and see it fail, and how property based testing will push us closer to the right point. So let's assume we didn't realize that we have this constant, the base Mars cars offset is the same, and we just have this sum here and we forgot, we didn't realize this is wrong. So let's just split this again and let's go to the test that we have here, and I don't think our no, impl from should be public by default. but okay, what we want to say as a property, we just say test. Let's just write it above this block because this syntax issue bothers me a lot. So we have a function, and that function should be called say what should be our property? Just say so we generate two hands and from them we generate two stars which represent hand. From them we generate hand ranks, and the comparison between them should be identical to the scores to the hand rank into U32's relationship. That's in theory. So let's just say prop into orders like partial ort, and we get, yeah, we need to generate the same thing here, but we don't care if it's an ace or not. Yeah, we will get the same syntax highlight issues before. So we also need aces, and we need a second hand which also has aces, and once we have that, we could say let just s1 equals s1, no, sorry, h1 equals hand rank new of s1 trim, and let h2 equals hand rank new of s2 trim, and then what we need to do is say prop assert EQ and say h1 dot into U32 compared with compare with H2. Oh, this syntax highlighting is killing me. Let's just say star for now. Maybe it improves the highlighting for a while. Okay. So it says to trim, so we don't. Oh, actually, yeah. It says to trim and S1 trim. Where is that new hand rank? Hand rank. Hand rank gets a star, gets a self. Okay. S2 is not in scope. Yeah, this is S2. So H2 into U32. And so when we compare that, it should be the same ordering as H1 partial CMP of H2, right? Wrong numbers from expected 0 from 1. Okay, maybe they don't need to say it because it's the only into. Yeah. Oh, monitoring. Oh, my secondary monitor just decided to go to sleep mode and I missed it. Come on. Okay, back. Good. Okay. Cannot differ type parameter t, declare or into. New. It's a self, so this is so what I implemented was, oh come on, from. Okay, so let's just say from H1 from H2 and I'm missing something. I think I'm getting tired from still convert from. Oh yeah, I guess still convert from EU32 from. That should be it. Okay, so it should be EU32 from. No? No. Expected in num. What don't we found in num option? Um, cannot find function from in scope. I'm not sure what's happening. Um, let's simplify this or split this into pieces. So let num ord equals to, let's just say this. Okay. And then no. From reference to each one. From reference to each one. Okay. Okay. Consider borrowing here. Okay, so just compare it. Okay, not sure why that was necessary, because I think this should have been okay. But then just say num ord should be equal to partial compare, and I think it's not because this is an option, so let's just say unwrap, and now this should be h2. Okay, compare with h2. So let's just see, combo check. Okay, so now we should have a property which should fail, because first of all the bases are identical, are 0, so this should be quite easy to identify. So we should get an initial I don't know, whatever type of hand, and get that. Okay, value failing input. Oh no. Yeah, no, actually, yeah, I know why it's failing. We said whatever times, including 0, so let's go back to the correct restriction. Okay, so now it should work. It should fail. The test should find, the property test should find our failing test case. So yeah, we have less greater, so left says it's greater, so the numerical comparison says that the left is less than the right, while the partial compare says otherwise. So this is 1, 2, 3, three of a kind, and this is a pair of two pairs. So three of a kind should be bigger than two pairs, and our just in order to clarify things, let's just say we calculate also separately the froms so we can print them. So let's just say let score 1 equals this, so it's this, and let score 2 equal this. Okay, and now we just say, oh no, sorry, come on. Okay, and we just print line and say score 1 equals this, score 2 equals this. Oh, you're confused about where the strings end. So this is score 1, score 2, and so we would get also the cases where everything was nice. Mismatch, yeah, of course. So now we say score 1 compared to score 2. And the parents are mismatch. Gonna test. So is there a way to maximize this from the keyboard? Let's just search for preferences. Yeah, keyboard shortcuts. And say maximize. No. Okay. Doesn't matter. So yeah, it would have been nice to also have the hands, but anyways. So in this case, yeah, I think it's worth it. So just say say h1, no, score 1, score off, and now let's just write this, score off this, and we will put S1 score 1, S2 score 2. Okay, so now we will will see something resembling some nice output. So we can see the shrinking of the test case. Okay, so we get 2 hearts. These are okay. So this is the first one. So it says, oh, it's okay. 2, 3 of a kind has a score of king, king, queen, jack, jack. So we have 3 of a kind has a smaller score than 2 pairs, right? And this is wrong thing to have, because where is the hand rank? Sorry. So we have 3 of a kind and we have 2 pairs, and our property test case says, okay, this is actually saying that, but this is what we can deduce. So this is a 3 of a kind, which has score 23, while our 2 pairs, which should be lower than 3 of a kind, have a greater score. So they don't have the same ordering. So now it should be obvious that we made this stupid mistake, and we say, oh yeah, so now we should say multiplied by 1, multiplied by 2, multiplied by 3, and by 4, and 5, and 6, and 7, and 8. So now, in theory, we fixed it, but we still didn't, because we didn't take into account the ranks of the cards. We might have some passing tests. Oh no, it didn't. Okay, this is nice. So it still detected. So it says, okay, this has score 122, this one has 133. And on the left side we have 10, jack, queen, ace, 10. Yeah, so we have, but I don't see what is the, oh yeah, so I guess the where is it? 10. This is a high card. No, it's a pair. So we have a pair. So we have a pair of tens here, which says, and now we have a pair, and here we have a pair of queens, and this is exactly what the problem is in our current implementation, where we just don't take into account that the the card that makes the pair, for instance, is the one that should have the most weight in our offset. So in both cases, these are pairs, so we have just one pair. This is the queen pair, and this is a pair of tens, but our score for the tens is bigger than the one for the queens. So what we actually need is not a sum, but we need to have some kind of weight associated with the position of the card within the vector. So because this code is very repetitive, I'm going to rework it, refactor it now, and I'm going to rewrite it let's just say let hand offset equals, oh, we need to be in a match statement so we can get the associated information. Okay, so let's just copy paste. Let's not worry about that yet. So we could say enumerate instead of map. So then we can multiply the position of the card with the rank itself, because in our vector is sorted on the first position of vector we have the most significant card, and then towards the higher indexes we have the lower the lower weighted ones. So we also need to adjust our cards, max cards offset, because now we realize that we don't calculate it correctly. So if we say, okay, the lowest card is a 2 or an ace, which is a 1, and the bigger one is also an ace, but when it acts as a bigger than a king. So for that kind of situation we need at most the offset of a single card is 14. So if we multiply the rank of the card with 15, sorry, the position, so if we enumerate the card on the first position with 5, what was it? I guess I'm missing something. So what I'm thinking is something like, okay, we have a base score for the whatever hand that we're talking about. Let's take a very easy example where we have a single associated U8. So for instance, straight. So for a straight, you in theory could multiply I'm wondering if there is any kind of way. Let's don't worry about this. I was thinking that maybe if there is some kind of way to so if we multiply just the card rank with the 5 minus its position in the vector, then we could in theory run into a situation where we have a pair of 2s and that's multiplied by 5 equals 10, and if we have something like a jack or a king or a queen on the lower position, that would score higher than the actual 2 pair. But let's let the property testing still guide us to that solution also. So let's try this first. So let's just say okay, enumerate, right? I think that was enumerate, and that should give us the position and the card itself, and we could then say 5 minus that. It's a U size, so we need to write it as something. So let's just say, I think we actually need to split this into, because it bothers me, this repetition. So let's just say let base score equals this, and then we don't care about so just replace, come on, this with this, so we don't care what is the payload. Now we do in that case, and we say this replaces is replaced with nothing. Okay, and now we say we want to return the base score plus the match hand, and this means that we can replace this with nothing, right? No, we need to escape this, okay. And we have a dot. Huh? And just kill this too. Okay, so we replace with nothing. Okay, so now we added the base score to the result of the match, and now we can rewrite this in a nicer way, and does it accept to say something like this? Unreachable expression. Any code following this expression is unreachable. Huh? No, I think it's wrong. But anyway, let's just say like this. Oh, I think it was incorrect. So let's just say, does it work? Cargo check. Does it like this? No, it doesn't. So I guess I need to explicitly say the cases, but then I will be able to replace such a statement with nothing, or just a pipe. Right. So what happened here? Okay, and now I just add the card ranks, and I'll say, okay, map, whatever, not map, but I was saying enumerate. Enumerate, and once I enumerate, then I could, oh, it's wrong. So once I do that, I could say I, and we get an X, and then say I as U32 multiply, no, 5 minus I as U32 multiplied by X as U32. What's happening here? I think it's catching up, yeah. So let's just see if cargo check is happy. Yeah, happy. So let's try again. I expect this will fail, but a little bit later, because there should be some kind of corner cases where you have twos that compared to kings or aces. Yeah. So subtract with overflow. Yeah, I think this means that our code, test code, is incorrect. 79 here. So we were saying 5 minus, oh, yeah, I guess multiply by X as U32. Okay. Okay, this is nice. So we get 10, 10, a queen, a jack, and an ace, and then a 10, a queen, a 2, an ace, and a queen. So we have a pair of queens and a pair of tens, and obviously the queens should have a higher score, but it doesn't. It has 225 and the 10 has 239. So this highlights the problem. So the problem is that this score 225 is actually calculated like this. Is so the biggest card here in our ordered whatever the vector has the equivalent of queen because it's the pair. So we're talking about the right side. Queen and then an ace and then 10 and then a 2. That is what we have on the right side. So that means this is 12, this is a 14, this is a 10 and a 2. So we get 10 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2. And if we add all of these, we should get 225. And we don't. Why? Oh, we also have the base score. The base score has this is one pair, yes, and one pair has an extra 75, 205. Yeah, that is correct. So, oh, this is actually another problem. Our base constants are incorrect. So now we have overlapping scores because the card ranks are so the biggest card rank can be let's say in theory. In practice it doesn't happen because we don't have such a big vector, but we could have in theory all aces, right? And that means that we have 14 multiplied by 4, so sorry, by 5 plus 4 plus 3 plus 2 plus 1. That assuming that we don't have any kind of we have all of them are aces, which never happens because, well, on our quick check it could happen. So yeah, we could have in theory 5 of a kind, but I think this will be classified as 4 of a kind plus an extra ace card, right? So let's just see. Straight 4 of a kind. Yeah, it will be a 4 of a kind. We don't have a 5 of a kind or something like that. So in theory this is the maximum score for an offset. So the base of an offset is 210. So let's just say the biggest offset is 210. So we just need to bump our max cards offset and say, because it's 210, let's just say the card offset is 250 and try again. So yeah, this is basically pushing us towards the correct solution, and we still should have an issue with the very strange corner cases with pairs of twos and things like that. So let's see what we have here. So we have a pair of tens and some other hands, and on the right hand we have a pair of queens, and the pair of queens is lower than our pair of tens, which is incorrect. So let's see why that happens now. So we have 250 as the baseline for the pair, to which we add a queen, which is 12 multiplied by 5 plus the ace is the next one, so it's 14 multiplied by 4 plus 10 multiplied by 3 plus the 2. multiplied by 2, and this should give us a whole 400, which it does. Correct. So then on the left side we also have a single pair, which is 250, plus we have the 10, which is multiplied by 5, plus the ace, which is a 14 multiplied by 4, plus queen, which is 12 multiplied by 3, plus jack, which is multiplied by 2, and that gives us 414, which is incorrect, because we from an ordering point of view, is because our pair of queens should be bigger, should have a higher score than the pair of tens. And this actually leads us to the situation where we say, okay, the trailing cards actually weigh too much, so whatever is on the trailing card should not overflow in terms of score over the most significant ones. So that means that we need to multiply each card rank with such a threshold that whatever comes after it never goes above that. So because we have cards from 1, that's the ace when it's in the straight from ace to 5, until ace, until it's 14, as bigger as the king, that means we could multiply the first position, so the first card in the vector, we can multiply it by 15 multiplied by 5, and that should give us the guarantee that basically whatever it's 5 minus position. It could be 4 minus position, but that's the same thing. I think it's actually nicer if we multiply by 4. So it's 60, yeah. So it's nicer that way. And in this case we can find out what would be the maximum. So let's first do that, and then we need to readjust our max cards offset. So our sum will be, let's just cargo format, because I think this line is too long. Yeah, and this is actually the way I wanted it to write it, but I was lazy. So we enumerate, and let's just say 4 minus this one, and we multiply it as U32, and we multiply it by 15. So each card is multiplied by this position plus 14. Yeah, it's okay. It should be okay. So now the biggest max card offset in theory should be 15 multiplied by 4 plus 3 plus 2 plus 1 plus 0, but that's okay. And assuming that all are aces, this is the maximum. So it's 2100. That's the maximum offset of a hand. So let's just say 2500, and that should give us the correct scores at all times, at least in theory. So now the two ordering functions should agree with each other, but they still don't. Okay, why is that? So we have a pair of tens and a pair of queens. Now that's interesting. Oh, I know, I know. The same way we have been we have been offsetting each of the card types, uh, hand types. We need to offset the card scores. So we should not multiply with x. We should add to something. So um, we should say something like this. So we this 4, yeah, 4 minus y, which is the index. So the for the first position we multiply by 4, 15 plus 4, 15 multiplied by 4 plus our card, and that should give us the correct score. And now we should be okay. So yeah, it seems that I didn't I was feeling that something was off there, but yeah, still failing. Interesting. So another pair of tens and a pair of queens. Yeah, but I think still the score overlaps. Overlap. So um, let's think a little bit. So the maximum baseline, just keep it as a 5. 5. And so we have, so let's just rethink this. So on the first position we have 5 multiplied by 15, which is 75, to which we add the card, which can be a maximum of 14. So let's assume that's a 15, because it's easier to calculate. On the second position we add a baseline of, we should add a baseline of 4 multiplied by 15 plus another 15. So for each hand we have 15 multiplied by 5, because this pattern repeats, and for these we have 5 plus 4 plus 3 plus 2 plus 1 multiplied by 15, which should be 300. Yeah, okay. Okay, so that's the maximum offset. Okay, that's the maximum offset of a hand. But I'm wondering if the score of any card is actually correct, because we have a baseline for its position plus the actual score of the card. So just say but something is wrong here, I'm not sure. So let's just assume that the biggest card rank is 15 for ease of calculation. So that's 15. I'm still wondering if this is if this shouldn't be multiplied. No, the base score needs to be there, but there needs to be what if we do so let's just say we just make this a little bit more readable like this, and we just say let card weight equals this, and then we say card weight, yeah, it's not necessary, card weight multiply this plus, and say again, it shouldn't be necessary, card weight multiplied by X's U32. So no, it's not the card, it's the position. Card with Control F2. Come on, rename. Okay. Okay, so position weight. Position weight. Yeah, so I guess this is the maximum, so gives us a base threshold by which you cannot go over with this. And then X is always lower than this. So you could have at most this in theory. So if we had X as 15, this could be multiplied by 30, right? Because your position weight so position weight multiplied by 15 plus X. I'm wondering why. No, something is wrong. I'm getting tired. So yeah, so here the tens here are not high enough. I think it's easier if I write down the scores. and realize what is actually the problem. So yeah, let's see if this fixes it, but I'm not confident, and I'm not sure this so let's just say 15 multiplied, no, it's um, 5 multiplied by 30, right? In theory that's the maximum. So it's 5, 5. Really? So it's 5 multiplied by 15 plus 5 multiplied by 15. Yeah, I'm getting tired. So it's 150. So I don't know. Oh, and this actually it's the other way around. So it's not complete. The calculation is not complete. So I have 5. Oh, I think actually think it's no. No, this is not good. This is not correct. Well, let's just keep it at this. So it's position weight 5 multiplied by 15 in theory by 30. Let's just keep it explicit. So 5 multiplied by 15, to which we add 4 multiplied by 15 plus 4 multiplied by 15, and so on and so forth. So this actually means 5 multiplied by 30 plus 4 multiplied by 30, and so on. So we have 5 plus 4 plus 3 plus 1 plus 2 plus 2, 1, whatever, multiplied by 30, which is 450. Okay, so let's just say this is 500. So this should be in a UK. Just say no, still incorrect, and still tens and queens. Yeah, and it's the trailing cards that are messing up the calculation. So yeah, so I'm not sure what is the issue here. Yeah, I think these queens are 10, 10, queen, queen. Yeah, I think these queens are have too small of a weight, so the 10 has too much weight, and I don't understand why. No, actually the last cards have too much weight, because this is 15. But I'm not sure why could, or how could that happen, because in theory the score of a single card is weighted by its position. So if it's on the first position as it is for the 10, it should have a comparable weight as the one on the same position in the other side, but not greater. For yeah, these queens and the tens are killing me. So for the rest of the cards, I have ace, queen, and jack, which are really big. While on the right side, I have queens, an ace, and two. So let me see why the score is that big. So let's write this down on some kind of separate file. So come on. Okay, so for the 10 we should have 4 multiplied by 15 plus 10. And then the next card is the ace, which is it says 3 multiplied by 15 plus 14. So is this always bigger than the next? So let's assume we have, it should be, but just double checking. So we have 4 multiplied by 15 plus a 2, which is the minimum, or the 1, which one is the ace. So that's 61 for the highest valued card in our hand. And then we have 3 multiplied by 15 plus 14, which is 59, which is correct. So there shouldn't be any kind of overlap, right? Okay, so let's continue. So still on the left side we have an ace, we also have a queen, so it's 2 multiplied by 15 plus 12, and we also have a jack, which is 11, right? Okay, so now on the right side we have 14 or 4 multiplied by 15 plus the queen, which should be 12. And the thing is that if the rest are just twos, should be smaller than our hand, right? So we have a no, this wasn't 3, it was 2, this was 2, 1, and that's it. So for the next one, we should have 3 multiplied by 15 plus, assuming this is a 2, this should be bigger, always, right? But I don't think it is. Let's just think of it. So this is a 2, this is a 1. So we have 4 multiplied by 15 plus 10, which is 70, plus 3 multiplied by 15 plus 14, 108, plus 2 multiplied by 15 plus 12 plus 15 plus 11, 197. Okay, and the offsets are 2,500. So if we add 2,500, we should get the score, which we do. Okay, on the right side we get queen, then we get an ace, we get 10, and we get a 2. Yeah. Okay. So the problem is that, okay, these are identical, so these don't matter in the comparison, but then these are interchangeable, which shouldn't be. So if I put this, I put the 10 on the first position, or I put the queen on the first position, these are interchangeable, which is not correct. So indeed there should be a way associated with the position also. So if this was 4 multiplied by this, I guess this would mean that this is 4 multiplied by this, and this is a 2 multiplied by this, this is a 1 multiplied by this, and this is a 2 multiplied by this, this is a 1 multiplied by this. Okay, so now this is 40, while this is 48. On the second position, this is a 24, while this is a 20. Okay, so let's just say position weight multiplied by x as whatever. So let's just see. Yeah, most likely the offsets are wrong now, but I think we can calculate some. No, it's still not okay. 250 maybe. Queens and tens. Yeah. So just put this a 5. So it's easier to calculate. Tens and queens. Okay, so what are the offsets? So let's assume, so we have 5 multiplied by 15. No, actually I don't think. Hmm. I'm thinking if the bases of the cards are incorrect or not. But they shouldn't be. Oh, it's the position weight minus 1. And then the card should position us within that section. So position weight minus 1. And I think so basically we have the baseline which is brought up by this position with minus 1 at some level, and then we get the card, which is still incorrect, but I think this is due to the offset, possibly. Queens and tens. Okay, so let's just put some absurd number here just to make sure that's the case. So let's just put 5 overflow maybe. So the 3, okay, 5, 3, 2. Okay, in theory that's, well, roughly. I'm too tired. I have to go to sleep anyway. So yeah, let's see, for 5,000 that's big enough. But I think this should be turned into a U664 or something, just to make sure we don't have wrapping. Yeah, so the scores are wrong, so it's 214 versus 300, and this shouldn't happen because so this highest position should, so no matter which are the other cards on the lower positions, this score should be the biggest. So let's assume I just have one card. Maximum score is 40. So whatever I have on the second position, we just have as a baseline 15 plus my card, right? So in theory, this could be but no matter which C we have, it should be smaller than X plus D, and X is something related to this value here, which is the maximum, which should be 15 plus 15, right? But I think this should be multiplied or something. Isn't this what we've tried here? Where is the calculation here? So let's assume we have a 2 here, or a 1. It should always be bigger, so this is x. It should always be bigger than this one. So in this case, x equals 15 makes this true. But so x plus 14 should be bigger than the next one, which it is. Okay, so x could be 15 in this case. And the biggest score here so the baseline of a card. Yeah, but I'm getting again to the same idea of let's see. So if we keep it simple, so it's 15 plus the card. Ah, tens and queens and plus the 2. Yeah, that's... yeah. I'll put a stop to this now. I'm too tired. I cannot think straight and it's way too late. So, yeah. Hope you enjoy this, in spite of the technical problems, and have a nice evening or day or whatever is left, or a good night. Bye.